Okay. Now, in some ways, this is a very humble presentation compared to the scope and ambition of the previous presentations, which are much more soaring in ambition. I'm doing something small, but it's real, and so I'll tell you about it. So, if you're spending any time in the FHIR ecosystem, you will come across a FHIR implementation guide. Now, FHIR implementation guide is a document that explains how to use FHIR to solve a problem. All sorts of different problems. Just amazing how creative people are. But all the implementation guides have the same format, which is they contain a set of human readable narrative in HTML format that describes how FHIR is used in a particular context to solve a particular problem. It also contains a set of computer readable resources, which are FHIR resources, that allow for tools to validate resources or create code or all sorts of other kind of leveraging publishing content. And we try to make as much of the human readable narrative computer processable as possible. And we publish a package, an NPM package that contains all the computer readable content. So that's an implementation guide. As an editor, when you're working on the implementation guide to publish to people what it is that you think they should be doing, you input a set of resources that contain all the computable rules, and they might be profiles and value sets and search parameters and plan definitions and libraries and medication lists and yes, all sorts of things, lists of locations. And then you input human readable narrative as Markdown or XHTML, and you just do you cycle through that 100 times as you work up your content. Now, then we provide a tool, IG Publisher command line tool, that validates all the input resources to check that they're all valid. There's a real deep validation on them to try and really work on the quality of your implementation guide. It generates this big series of XHTML fragments, hundreds, thousands of them, maybe a million if you've got a big implementation guide. And then we execute a program called Jekyll that stitches all the fragments and the human supplied narrative bits and everything all together to produce the human readable output. Then we check that for broken links so that there's none of them, as much as little as we can have, and we build the output package. Now that tool is not a editor friendly tool. It doesn't do WYSIWYG editing or anything like that. It's deliberately the back end of the tooling process. There are other tools that work on the authoring process and make it easier. The IG publisher has always focused on the assembly and validation and correctness of the output package. Now, we actually literally had this discussion when we started writing the implementation guide publisher that we would expect to see a total of 100 implementation guides. But in fact, well, publicly, I've seen 1,000 plus different implementation guides. Just utterly amazing compared to what we expected across all the ecosystems. And I suspect that I've only seen half of them. There's a lot of private company work now being done on the IG publisher. And it's being used in very surprising way as a general purpose publishing tool in healthcare. I spent this week working with a government agency that wishes to use the IG publisher to publish their web view of their medication list. And it's had considerable investment from the US government and some investment from WHO around multiple language support. And maybe this is a very narrow use. Now, when you build what I've described is very much two different perspectives. A set of input from structured resources that describe content in computable ways, or narrative, which is just ad hoc, human authored, Markdown or XHTML. We don't care about that bit. But it's really good to be able to, in the narrative, quote from bits of resources when you're discussing them. So you don't have any risk that your little fragment, you're explaining something to an implementer, doesn't get out of sync with the actual examples or the actual content that you're describing. But also, it's really good for you to be able to put summary tables into the narrative to help the user navigate and understand what is the scope and the content of the implementation guide. And today I'm going to talk about how to build summary tables that navigate across that include content from multiple resources, and we use SQL on FHIR to do that. So here's an example of a implementation guide. It's not a particularly special example. It's an implementation guide that describes how to do a formal way to do vital signs correctly. In the base specification, we say a vital sign and we fix the units and the codes, but we don't formalize the description of all of the metadata and related qualifying data and methodology data around vital signs. And so that's what this implementation guide is doing. And I chose this as the example implementation guide for me to work on as this example. And what we want to do is have a summary table that contains all the vital signs. And we're going to work towards a summary table of that just to see how it works. So this is from the base specification where we have one of these summary tables. This summary table here in the base specification is, no, sorry, this is where I started with the implementation guide. This is a manually written table in XHTML that the author maintained to show the user as to help the user understand the content. So we're going to replace that with an automatically built table. So we want to add a table summarizing those examples. And as I said, it's building by hand is tedious and it's easy to make mistakes and miss things and get out of synchronization. So we want it built automatically. So we can do that. So SQL FHIR, we've talked at the end of the show, so you all know that you can flatten a resource into a row and or a set of rows, and then use SQL with it. So we'll do that. Okay. So to give a little more context, we already have SQL support inside the IG tooling. So first thing is that the IG publication tooling produces a database file, which is an SQLite database containing a summary of the content in the implementation guide. And it gets cut up and turned into the resources are analyzed and processed, and we produce various views automatically in the code of the IG publisher to help consumers who are like, I've got a lot of JSON to read, just give me a database. And so there's your database. And I occasionally add things to make life easier again for people. And here's some of the tables in that database that we automatically produce, a list of code systems and codes and concepts, and a list of resources, analysis of what's in value sets. Those are things that various implementers have found useful. And here's a list of the actual resources. So you can quickly see the type, the ID, the web URL of the URL of the official URL of the content. And so you can already use that. So what we want to do is use the view definition to add additional tables to that database and then use what's in that database to generate narrative. So your basic 4 steps to do this is you have to register the view definition so the IG publisher knows about it. Then you have to actually fill out your view definition content. Then you build the IG and check that you've got the QA right and iterate until the IG publisher is happy with the view definition. And then you can do SQL in the pages. So we'll just work through those steps quickly. So first of all, just tell the IG publisher about a view definition by saying, here's a view definition and a path inside the repository that's all the source content for an implementation guide. This is shown in the sushi format, but there's a bunch of other different ways to do this, but they all come down to a parameter to the IG publisher, which is a view definition and the actual view definition. So here's the view definition here. We're going to summarize observations. We'll have the resource key for the observation, then the ID for the observation, profile code, And these are the different things that we're picking out from the observation. This is a super simple view definition. For this case, it's just a linear flattening of a resource into a single row. We could do much more complicated things, much more ambitious things, but it's not the goal of this presentation to show you how to do complicated things with view definition, although some authors have. And then we build the IG, and one of the things that the IG does is there's a QA file that's always produced that lets the author know if there's any observed issues. It's a quality step. And in this case, the IG publisher looks at it and says, well, actually, there's some issues here. I want to warn you about this. Now, this is a closed system because the author writes the view definition and the author inputs the content. So let's look at this. If you go back and see, we said the profile has meta.profile. A meta.profile is actually a repeating field. And so the IG publisher says, wait on, hang on, I'll show you here. Wait on, you said that there's a single field that's a meta.profile, but meta.profile can repeat. That could be a problem. So the column is not defined as a collection, but the pass statement might return multiple values for some inputs. Now, as the author of the IG, you know that it doesn't, right? You know that you're only ever going to provide one profile. So you know that's okay. But the IG publisher doesn't know, so it's warning you. And so it might give you some errors where you actually referred to paths that don't exist or mismatched types or whatever. And so you work through that until your IG is fine. But in this case, no, before I do that, one of the things that this is QA check on the view definition. And if you want to take advantage of the view definition QA checking part, the validation outside of the IG publisher, you can do that because all of this is in HappyFire core in Java. This is Java, but it's all Java. And then there's a set of classes, a runner that actually reads the set of resources and pushes data into the storage. I don't know if it says runners, that's a mistake, into the different storages. The validator checks the view definition against the FHIR schema and storage SQL, and then there's two storages that produce storage output. And the focus for this work is the SQLite output that pushes it into SQLite 3 database. So we revise. So we have issues here. For instance, I talked about meta.profile, but the same applies to code, where a code can be one-to-one, but a code can have multiple codings. So code.coding.code could be a collection. It won't be, but we can actually correct that and say, well, let's be specific. So we'll clean out all the errors. Meta.profile, only the first, and only the first coding. Now I know as an author that I'm not probably going to violate those, and so I didn't really need to do that, but it's very good to be careful and precise. Okay, so now we have our complete view definition, and it's got no more issues with it that we need to address. And so when we actually look at the database that's produced by the IG publisher as part of the run, it now includes this table observations view as defined by the view definition that we created. And so that will always be produced every time. So that's great. Now we got that. And we also produce as a output a JSON file using the other storage system, which has the same information as is in the database, but in a JSON format. And so that's just for convenience for users. You want to read it as a JSON object, go right ahead. Actually, JSON array in this case. You want to read it as a database, SQLite database, go right ahead. We just produce both forms. Now, having done that, what we want to do is take that view that we created in a database and put it in the narrative so that a human reader can see that summary. So the simplest way to do is just to write as SQL that selects those columns and dumps them into the narrative. And the way we do that is use these typical liquid tag surrounds and then say that we're going to run this SQL, and then here's the SQL. And the IG publisher will scan the pages human authored pages, find this liquid insert and process it and inject that into the resource, into the narrative output. And there you see so we have the list of resources, their ID, their profile. This is exactly as described by the fields that we chose. And you can see that the IG publisher instantly knows that this is a profile, a URL, and so it knows to resolve the URL and turn that into a link in the HTML. But we didn't. We could do better than this. We don't really know very much. We don't automatically know any metadata that allows us to turn all these other strings into links, but the author does actually know those things. So we can work on that by providing additional metadata. And we can say that, look, the code comes from loink.org. We know that that's the case. And so when you display the code, display it as a loink code. And then the site will be a SNOMED code. And by so doing, we can add additional information around the same query, but we've just filled out additional metadata about each of the columns. And then the IG publisher just uses those to do a better job of rendering the table. And here we go, our fully rendered table with links throughout the IG or to external resources that provide full definitions of the content. And in this case, you can see one of the things I wanted to point out is that we collapsed we took this ID and hit it into the other column so that that first column becomes actual link to the IG. So there's various things that you can do like that to improve the overall representation. You can see that as well. From here, we just had a bare code, LOINC code 96607-7. And here, because we told the renderer that it was a LOINC code, we could actually look up the meaning of that LOINC code and tell you that so that you know what LOINC code it is. All right, so here's a summary of the documentation. These are pointers to the actual definitions that I used in this case. This is a pointer to the documentation for the use of the SQL view definitions in the IG publisher. And finally, some places to find me. And yes, we will share these slides. Ian, I will send them to you for wherever we're going to share those slides. So thank you everybody for listening. As I said, that is a fairly unambitious use of the view definitions compared to some of the grand usages that you've seen up till now. But I hope that you found it interesting. And for us, it's a good way to empower authors to provide better views of the content of their IG without having to author stuff manually and the attendant risk that they'll make mistakes or let things get out of sync. And if you've ever edited a document, you know how easy that is to do. So thanks for listening, and I'm happy to take questions for a little while.
All right, thank you very much, Graham. Don't see any specific questions in the chat, but we have a few minutes and until 11:15. So, as someone who is at the heart and core of all things FHIR, I'd just love to get your thoughts on what we've been working on in the FHIR Analytics Collaborative, SQL on FHIR, and where things are going. Where do you see the applications of the technology that we've been working on heading into the future?
Well, I think that it's really interesting because the focus with FHIR is on operational data, and that is data that is precise, that is very contextualized, that it meets people's, operational requirements. And everybody in health wants to do QA so that they can improve their processes. And it's really hard to do QA on that on data like that because what you want when you start doing an analysis is tabular data and statistical, so you can apply statistics. And so really the question is, what's your path for getting to that? And A lot of people think in terms of there's existing tools that help you do that, but they're really focused on tabular input. And so then you have some kind of ETL, an extraction and transformation process to convert from your raw data to your analytical ready data. And so the question is, what is that process? So there's a number of ways to go about it. You can simply build really, really large bucket loads or, lakes of FHIR resources and then project them into specific tables with custom code. And probably that's the most efficient approach for full-time professionals who do this all the time. But you could also, alternatively, you could say, well, I'll just convert the data with a custom ETL or a commercial ETL or some kind of, shared ETL process to OMOP, which is a particular view of what an analytical ready set of data is. And OMOP is really, really good for standardizing data, but only if your questions are the kind of questions OMOP anticipate that you'll be asking. And some of them are, and some of them are not. But for me, the view definition work is a middle path where you can have shared infrastructure that makes it easy to write just the logic of what you're trying to achieve, to flatten the nested data into flat tables. And so it's good for analysis, but it's also good for operational systems that need to do joins across large sets of data and really leverage relational database infrastructure. And so I think that I recommend to all of the implementers that I work with that when they get to talking about doing an analysis of the vast amounts of data that they're moving into FHIR, that they should start by saying, well, we're going to use the view definitions to create our tables that we can do our analysis from. And then if that turns out we can do better than that, then we can invest the work in some other kind of approach. But I think it's a really good place to start, and I think it'll meet a lot of people's uses outright. But the one of the
Well, that's
questions,
excellent. We appreciate the plug, by the way.
yeah,
We appreciate
that's all right.
your
That's all right.
advertising.
I think the questions that we're really going to explore over the next few years with view definitions is how much data massaging can you or should you do in your view definitions as
Mm,
opposed to post view definition. And
mm,
and I keep wanting to do more and more in the view definitions, but that makes the infrastructure more and more complicated. And so there's a tension
mm.
there.
Yeah, that's an interesting point. Yeah, just for the audience, Graham, the panelists, and several other critical folks who are not on the call. We'd been working through this tension for probably 3 years now in terms of view definition, how complex to make it. There's a specific, there are specific tensions, and you have to pick some spot on that continuum. In many ways, we experimented and approached more complex approaches and came up with what you said is sort of a middle path. We want it to be usable, we want it to be very implementable. And that's why I think you see this growth in view runners and implementations that are very fast. Like I mentioned yesterday, people just read the spec like yourself, Graham, and implement a view runner on their specific data environment and then let us know about it, right? Some are 500 lines of code, and there's great open source examples. So if you have a specific data environment, you go look at the list of, say, open source view runners or even commercial ones and say, well, that's not my data environment. Right. I have some specific data system. It's well within your capabilities or the capabilities of your organization to develop a view runner. And that's why we designed it, I think, in part in that specific part of the trade-off. But, the question is still valid. And I think we've seen examples of people doing more and more complex work in the view definition pipeline. So that'll be an interesting place to go forward. Yeah, I certainly agree with that.